All right, what we have here is we're going to be talking about factorials. All right, factorials, or the fact about Orioles. What are factorials, or I like to say factorial, all right? Because when you have a factorial, you're talking about this exclamation point. This exclamation point, not explanation point, sorry. I sometimes say that incorrectly. This exclamation point refers to and is used quite a bit in statistics, okay, in probability. And what this means, or the definition of a factorial, is that we are multiplying consecutive numbers together. So if you have n factorial, we're multiplying 1 times 2 times 3 times 4 times 5 times 6 times dot, 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 dot. Keep on multiplying all the way up to n, because it's n factorial. Now, we also are multiplying by this one by its previous term, which would be n minus 1. And the previous term right before n minus 1 would be n minus 2. And we would multiply all these values together. Now, some things that you should know about factorials is that 0 factorial is equal to 1, And 1 factorial is also equal to 1. And so when you're finding, for example, 5 factorial, that would be like 1 times 2 times 3 times 4 times 5, which is going to equal 120. After you do factorials a little bit, you get to generate these numbers rather quickly. Now, we have 2 different examples of using factorials. And just so everybody knows, a factorial can be found on your calculator right here. And if you have the factorial button, we can actually find the first couple of terms of this by going to our calculator and kind of typing this into our y equals. So if you go over here, you can go to this. I'm going to type that in there. And I'm just going to make it like x because sequences are very similar to functions. So I'm going to go to my y equals. I'm going to have x. I'm going to divide that by x factorial. Now, where do you find the factorial feature? If you press math and go over to probability, all right, or PRO, maybe people may have that, and you go down to 4, it's in the probability section. Like I said, factorials are used a lot in probability, and we have that. If we go over to our table, we can then start generating some values. So for example, if I want to find the first term, we can identify that the first term is going to equal 1. All right, and the reason why is because when I find a sub 1, that's going to be 1 over 1 factorial, which is 1 over 1, which equals 1. And there we have it. We can find our next value right here by plugging in 2. So we plug in 2, find our second value, and that's also going to equal 1. All right, and we can kind of figure this one out. This right here minimizes this. Okay, and we can do this by going through and plugging these values in. So if I want to find my second value, we can go 2 over 2 factorial, which is 2 over 1 times 2. Cancel, cancel. We're left with 1 over 1, which is 1. And you can do this for all of them. 3 factorial, we have 3 over 3 factorial, which is 3 over 1 times 2 times 3. Cancel, cancel. We get 1/2. And you can put this in your calculator and generate these same values. We have 4 over 4 factorial, which is 4 over 1 times 2 times 3 times 4. Cancel, cancel. And we're left with 1 over 6. And finally, the 5th term is going to be 5 over 5 factorial, which is going to be 5 over 1 times 2 times 3 times 4 times 5. Cancel, cancel. And we're left with 6 times 4, which is 124. All right, 1/24, and that's going to be our solution. So that's what we have with factorials. Factorials are also used in number patterns. For example, if we want to find the nth term, or if, remember, the nth term is an equation, all right, an equation for this. Given our first term, which is 1, and our second term, which is 2, all right, and our third term, which is 2 squared over 2, and so on and so forth. And I like to write these out because whenever I have fractions, I like to create all fractions. And you can kind of see what that number pattern will be. Now, what you notice is that we have 2 different changing values. The bottom, we see, has a pattern of 1, 2, or 1, 1, 2, 6, 24, 120. That pattern is actually a factorial pattern. So we go n factorial. The top appears to be, what we're having is 2. And we're raising that to the n power. Well, actually, it's going to be the n minus 1 power because what we have right here is when we plug in 1, we get 2 to the 0 power, which gives us that 1 in the beginning, so we have 2 to the n minus 1. Okay. Now, some other examples of how to use factorials and how to simplify that is we're going to go through some other examples. Is that a lot of these you can put in your calculator, but some of them you can't. But a lot of them, since they cancel out, it's kind of really easy to simplify. So, for example, when we have equations like this, okay, and we have factorials, you can kind of think about this as we're starting at 10, and we're going all the way down to all the numbers down to 1. And so when you match these up, I like thinking of it as a game. And what we have is 10, well, 10 factorial. Well, that is very close to 6 factorial. So if I wanted to simplify this, I can say, okay, I have 10 factorial and 6 factorial. Well, those would essentially cancel out, at least up to 6. So this would cancel with this one. What we're left with is, well, it would be 10, 9, 8, and 7, because everything up to 6 has already been canceled. The next one, what we have is 3 factorial and 4 factorial. Well, this one would cancel that one, but we're left with this right here, all right? And in this one, we're just left with a 4. And that would be our simplified solution. Then you can go on your calculator and figure those out, and you realize you have a really big number on top, but that's how you can cancel it. By thinking about these same things, we can come to a more complex expression, and you see this a lot in Calc 2 when you get to advanced stats. You deal with factorials in this manner a lot more. Now, I have x here. Many times you'll have n, and I'm going to put an n there. Okay, but what we're going to do is we want to simplify this ratio. So when we simplify this ratio, we have n minus 2 factorial. So I'm going to write this out, okay? And I guess I could have, and what I do is I just write it out starting at the highest value. Now, when dealing with these, it's a little bit more difficult to kind of have a number value. However, I'm going to start with having n minus 2 on top. Then it's going to be times n minus 3, then n minus 4. And I usually write the first couple terms, and dot, 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 goes all the way down to 1. Okay, times 2, times 3, and so on and so forth. Now here, with n factorial, we do the same thing. So we have n, and then we're multiplying this by n minus 1. And then the previous term, which is n minus 2. And I do this because hopefully you realize that, hey, you start realizing that, oh man, this is actually the same numbers. We're using the same thing as we did over here. Notice that we have 10, which is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. With that one, this was 1 times 2 times 3 times 4 times 5 times 6. I realize that this whole section can cancel out with this whole section, and I just have to write out the ones that are left over. And that's where this section right here is 10 times 9 times 8 times 7. If you didn't get that before, hopefully you got it now. Okay. Well, we do the same thing here. And what we realize is that, hey, this part of this entire expression, or actually the entire top, does cancel out with the part of the bottom, all right, which is right there. And what we're left over with is then 1 over, well, n minus 1 times n. And that would be the simplified expression. Okay, so those are factorials. Factorials are when you multiply consecutive numbers together. Okay, they're used a lot in probability. You can use them on your calculator. You can use them to find out number patterns and also to simplify different expressions. All right, hopefully this helps you understand factorials and how to use them. Good luck and God bless on the rest of your assignments and learning more about math.